Hello, hello. Today I have another modular zipper puzzle with, again, by heliopolix. This one's called the Haunted Lighthouse. And just looking at as soon as I opened the puzzle, I was immediately struck by the visuals here. It's very haunting. Hopefully the logic is not quite so haunted. We've got this little haunted eye or something in the center here. Very spooky. So anyway, what are the rules? I've got zippular lines. So on this line and all the other similar lines, if I have a digit in the center, let's say this is 5, then the sum of each pair of digits that are equidistant from that center has to have the same sum mod 3 as this. So 5 has a remainder of 2 mod 3. So whatever this sum is going to have to be in that same group of numbers that have a remainder of 2. So this could sum, I guess can't sum to 2. It could sum to 5, or I could have a 1, 4 pair or 2, 3 pair. It could sum to 8. It could sum to 11. It could sum to 14. Well, I guess that would be 6, 8 there, right? So I guess it could also be, no, never mind. So that is it. And that's going to be true of every single pair going off. So that's the zippular line. I've been doing a bunch of these lately, so hopefully that's somewhat familiar to people that have been watching for a bit. I've got a single cropy dot here, which says that these two digits have to be consecutive. So if this is a 4, this has to be 3 or 5. And finally, I have these remote sums. I had actually never seen remote sums before this puzzle was submitted. And so heliopolix actually gave me a couple of training puzzles to get used to this idea. But the remote sum rule says if I have this 7 cage here, then inside the cage will be some digit, which we'll call x. And that digit x is going to give me, let's say it's 2. That's going to tell me that 2 digits away, x digits away, whatever's in here, so in this case it's 2 cells away from this cage, either here or here or here, is going to be the complement that adds with 2 to give me the cage total. So that means I'm going to have a 5 in one of those 3 spots in order to make this remote sum 7 cage work. So the remote sum always is going to kind of refer to 2 numbers. There's the digit in the cage. The digit in the cage is going to tell me the distance to the other digit, and those 2 digits will sum to whatever the cage total is. And you can't go diagonal. I can't have like these two and say, oh, here's 2 and that's a 5. You can't go over and up. It's got to be in the same direction, either vertically or horizontally away. So those are the rules. Let's give this a try. I'm immediately drawn to the center because of the swirling pattern and all the 10 cages. But I don't, what can these be? Because these have to be fairly low. 1, 2, 3, 4, 5. Yeah, so actually these all have to be 1, 2, 3, and 4. Because if it were 6, if any of them were 6, they would go off the grid. Because nothing in here could have a distance, nothing in here can go a distance of 6 and remain on the grid. If I'm over here, I can just barely stay on the grid with 6. So it doesn't work. It doesn't work in box 5. And then what? And then this, by the same logic, has to be 5 or 6. Because if it's 8, this can only be 5, 6, 8, or 9, because they need 2 digits that sum to 14 that see each other. And if it's 8, it'll go off the grid. And 9, of course, will too. So that's 5 or 6. Can I use something like that here? Well, and if this is 5, even 5 is too big to go sideways. So if this is 5, we get a 9 here. And if it's 6, we get an 8 down here. What about this? This could be 8, 4. That seems okay. 7, 5 definitely works. 6 won't work. 5. So 5 doesn't work actually because 5 would go here, which is not 7. 3 or 4. 3 doesn't work this way, but I'm sure it works this way. The 9, 4, 8 probably is okay. Yeah, 4. I was thinking to be careful with 8 here, but 8, 2, 8 works, or 8, or 4, 8, 2 also works. Okay. Can I figure out this sum? Yeah, because these are two different groups. So these 4 digits sum to 10, right? Because they're all the digits 1 to 4. And these two have some modular sum that's the same as these. So whatever that is, if I multiply it by 2, I get the same as 10, which is the 2 group. So it's got to be the 1 group. No, sorry, it's the other way around. 10 is 1. 10 is 1 mod 3. So half of 1 is 2 in modular arithmetic, which is kind of a weird thing to think about. But half of 1 is 2, because 2 times 2 is 1, is 4 is 1, right? So this is 5 or 8. It can't be 2 because 2 is taken. Oh, does that interact with this at all? I think either way still works. If you have 5, 9, 8 is fine. 6, 8, 5 is also fine. But interestingly, either way, 5 and 8 are taken. So what do we say here? It can't be 9 because that's too big. It can't be 5 or 8 because 5 and 8 are in this column somewhere from this 14 sum. Because let's say there was no 5. Let's say there's no 5. This has to be 8, 6, but then the 6 needs an 8 here. It doesn't work. Let's say there's no 8. This has to be 5, 6. But this is an 8. So it just doesn't work. It just doesn't work. 5 and 8 are accounted for between these 3 cells. So this is 3, 4, 7. 7 would put a 5 here, which seems pretty reasonable. 4 was an 8 here, which also seems reasonable. Interestingly, okay, so if I can get rid of 3 here, this becomes 5, 8 for sure, because either this is 4. Oh no, because 4 could put an 8 on the side. Never mind, that's wrong. That's wrong. Okay. That's wrong. So what is the way to do this? So this is because these sum to 5. I mean, I guess they don't have to sum to 5, but the only way to get a 2 group here is to sum to 5. It's either 1, 4 or 2, 3. And I'm trying to think if I can get rid of either of those somehow. It's probably these 10 cages. Like 1, 4 here seems kind of hard because these would then no longer have. So to get to 2 in 2 digits, I have 2 choices. I can either have 2 digits in the 1 group that add together, or something from the 0 group and something from the 2 group. Those are the only 2 ways to add to 2 with 2 digits. So if this is 1, 4, the possibility of 2 in the 1 group is gone because the only digit left in the 1 group is 7, which means a 7 would have to go here. So if this is 1, 4, I get a 7 in one of the 10 cages. Let's put it here. It doesn't matter which side. That's going to give me 3. It can't go up or down here. Which gives me 1, 3, 4, 7. And then what is this? It's 2. It can't be 6 because that would put a 4 here, which is contradicted by 1, 4. I think it could still be 8. 8, 2, 3 works. Wait, hold on. If I know this is 1, 4, then therefore these aren't 7. I'm going to know the modularity of everything. So let's count the modularity. If that's 1, 4, then these are the 1, 4, 7 group. These have to be 1 each from, or 2, each pair is 1 each from the 0 group and the 2 group. So this would be from the 0 group because this is from the 2 group. So all these together would be 3 from the 1, 4, 7 group, 3 from the 2, 5, 8 group, and 2 from the 0 group. So if we're in the 1, 4 world, that's 7. I mean, either way, but symmetrically, I'm going to assume that's 7. And this is then 3 or 6. 3 couldn't get a 7 down, but it could get a 7 from one of these. Oh no, it can't be 3 because 7 needs a 3 here. So it has to be 6, but it can't be 6 either because that requires a 4, which is in here. So it doesn't work. It's kind of complicated. I wonder if there's an easier way. Like, I think it's fair, but I'm not sure if heliopolix tends to think things aren't fair that I think are fair. So I'm trying to think of a different way to get to a similar spot. Um, can I use, so if this is 1, 4, I know I need a 7 somewhere. And I think it's very fair to say that I know that those are both a 2 group and a 0 group pair, which means this 7 would go with a 0 group, which would make this 4 or 7. I don't see how that happens because this is 2, 3 in that world. I don't see how that helps. I mean, yeah, this being 2, 3 automatically gets us 4, 7. Maybe that's it. If this is 1, 4, that's 2, 3, which makes this 4 or 7. So if that's 7, that's automatically a 3, 6 group. And it can't be 3 because the 7 needs the 3, and it can't be 6 because the 6 needs the 4. That seems pretty fair. I feel pretty good about that. So that's not 1, 4. Therefore that's not 2, 3. So that's not 4. I still don't know which group this is though. Okay, now I can't put a 7 in here. So there has to be a 7 on here with 1 or 4. The other one is going to go in here. So one of these is in the 1 group. So one of these is a pair, and one of these therefore is a 0, 2. Okay, so I know the modularity of all these. So I've got, in here I've got a 0 and 2 2s. Here I've got another 0 and a 2. So 2s are gone and 2 zeros are gone. These are 2 1s. So what I have left is a 0 and a 1, which means this is a 1 in the 1 group, which means it's 7. Which means 7 goes off the grid, so that puts a 5 up here. I'm going to start coloring remote sums that I complete. And the 5 means that means that's a 9. And that makes this an 8. So, okay, well, this can't be 7 or 8 or 9. 6, 4 is still okay. In fact, I can't have 3 and I can't have 9. I need something from, so one of these is a 6. So one of these is a 4. Okay, so one of these is 6, and the other one is from 1 or 4. I can't go with 7, but it can't be 4 either because 6 needs a 4. Like this 6 would need a 4 here, this 6 would need a 4 here. Either way, I know 4 in the rows in one of those spots, so it's not in the cage. So this is a 1, 6 pair, this is a 2, 3 pair. 4 is going to go with 7, so that's a 4, 7 pair, and this is now a 5, 9 pair. Yeah, that feels very like a good flow. So I think that probably was the right. I mean, I don't know if I exactly got the intended way of thinking about that, but I think that probably was the way to break in. And then what do I have left here? I only have 3 digits, 2, 3, and 6. And then I should know the modularity of this from all that. So this is 1. These two together are another 1, so that's 2. Another 1 makes 3. Another 1 makes 4. That's zeros. We're at 4, which is 1. So this has to be 2 because the whole thing has to be 0. So the only thing in group 2 is 2. Now I know the modularity of this is 0. I can't put a 9 on I can't put a 9 on either of these, right? Because a 9 would need a 3 or a 6 here. So one of these is a 9. And then what? How does this, whichever one of these is a 2 needs an 8. I can't get it from the sides. It's got to be up or down. This can't be 8, so it's got to be down. So one of these is an 8. An 8 is going to go across from 5 because 2 is taken. So to get to 1 from a 2, I need another 2. So it's a 5, 8 pair. Then here I've got 3, 6, and 1, 4, which are going to go 3 and 6 from one group and 1, 4 from the other group are going to go across from each other. But they could go like 3 and 6 could be here with 1 and 4 here or something like that. Or I could have 3, 6, 1, 4, something like that. Either one would be okay. These are pretty low. Do they have to? So either they're 2, 5 to get here, or they're 1 from 1 or 4, which completes 1, 4, and 1 from 3 or 6. I don't see, I mean, either way seems fine. I get one of these, they can't have 7 because 7 would need 1 or 4. So 7 is in one of these corners. 5 is going to go in one of those corners with 6 or 9. And the other 6s or 9 is going to go in the other diagonal. I probably can do something here. How'd that work? This is a 1. Those are 1. Those are 1. So altogether, that's 0. So these sum to 0. That's a 1. So these are a 2. So how do I get 2 here? It's either 7 with 1 or 4, which doesn't work. So that's not 7. That's 7. So this is 3, 6, 9, 6, 9, which means that's a 2 group. The only 2 group left is 5. So that is 5. Oh, weird. So I get 6, 9 over here and 5, 7 over here, which means that's 8 and 5. Again, 8 over here somewhere. Oh, the 8. Why do I know there was an 8 there? Because the 2 pointed at the 8. So this 2 can no longer get an 8 and 8. Oh, can this not? Yeah, the 8 can't go in that cage because it's too far from the thing. So this can't be 2. So that's 3. The 2 needs an 8, which it has. So I'm going to gray this. The 3 needs a 7. It can't get it there. I think it could still get it there. It can't go down. So it's either this 7 or up here. What happens if that's 7? 7's in the 1 group. I would need 1 or 4 here, which seems fine. Okay, so I don't know where that 3 is getting its 7 from yet. What about this 1? It's going to need a 9. But lots of places to get a 9 still. Okay. What do I do next? 10. What are these 10 cages? Because they have to be less than, they're not 3, 5, or 6, actually. So they're 1, 2, or 4. And they have to add together to make 0. So I need a 2 for sure with 1 or 4. 2 is not here. Sudoku, so that's the 2. Where do I get an 8 from here? I suppose I could still get it here, right? I probably know the modularity of this. Okay, that's 0, so that's 0, that's 0, that's 0, that's 2. So these add up to 1. One of them's a 9. So the other one's a 1. So that can't be 8. I need an 8 here. And the other one is going to be from 1, 4, 7. And this is 1 or 4, 7 as well. Because they add to 0. 8. So 2 and 1 make 0. Yeah, I think that's all okay. So now 8, 8. Trying to look for some Sudoku, not seeing anything obvious. How is this 4 going to get a 6? 1, 2, 3. Because it can't get it up. Can't get it down. So it's going to get it from one of the sides. Either way, wherever it gets it, wherever the 4 gets its 6, it's going to rule out a 6 from here. So 4 is going to go next to 9, which means 1 isn't. So whichever one is 1 has to get its 9 above or below it. And this one can't. So this can't be 1. Because if this is 1, that's 4, which makes that 9, which makes that 6. This is 3 or 6. There's no 9 around it. So that's 4, that's 1. The 4 gets the 9 because one of these is going to be 6. So I get 6s weirdly in the boxes and rows here because so one of these is a 6 from the 4. If that's 6, that's not, so then this is 6. So if this is not a 6, this is. If it is a 6, it is. So in the cage, sorry, in the box and in the column, one of these is a 6. Same thing over here. I'm tempted to gray this in, but I'm going to wait until I actually place the 6. 1 gets the 9, so that's done. 3, can't get a 7 down, can't get a 7 up, so it's, and can't get a left, so it's got to be this 7. And then, yeah, 4 is one of the 6s. 2 needs an 8. It's not any of those, so that's the 8. That's filled in. 8 needs to go to 0, so that's in the 1 group. These also need to add to 0. So they're either 3, 6, 9. That's one possibility. Better. Where does 9 grow? Because it can't go in the 7 cage because 9 is bigger than 7. So 9 has to be in one of those spots, which means this is a 3, 6, 9 triple to get to 0. Which means I need a 5 in one of these. And the, better, where does 7, same exact logic, where does 7 go here in the row? Can't go in any of these, can't go in the 7 cage, so that's a 7. Puts a 7 in one of those by Sudoku. What do I have left here? 1 or 4 or 5? This becomes a 1, 4, 5 triple. 1 can't take a 6 down or up because I will break this, and 1 can't take a 6 over. Same thing here, right? 1 can't take a 6 down because that breaks this, or up or over. So these aren't 1, they're 4 or 5 pair, which makes this the 1. I get a 9 here. So that's 9, not 8, 9. I should know a digit here is, I don't know, I know all the digits. That's a 4. That's a 7. So this is 3, 6, and this is 1, 4. Very neat. This is a very neat puzzle. I still know this 4, right? The 1 needs a 9. It can't be up, down, or left, so that's a 9. And that gets grayed. I did this wrong. That's a 6. How does this work with a 5 could be 2. 4 could be 3. 2, 3. That could be 3. That could be 2. No, this can't be 2. And this can't be 2. So this can't be 5 because 5 can't go up, can't go down because it's 2, can't go over because it's a 1. So that's 5. That's 4. This 5 cage is done. This 4 cage gets a 3 either here or here. Either seem okay. This is this somewhere here. These add to 2 and these add to 1. Can I do something here? 5, 6, and 7 are gone. So this could be an 8, 9 pair. I have to go this way. 8, 9. Oh no, 9's here. So this can't be high. Well, 5, 7, 9 is right here. So yeah, this is low. It can't be 4 here. If this is, I'm trying to get rid of 4, 3 as a possibility because I can force a 2 here. I guess that's not that useful. So I don't see an obvious way forward there. How about here? These sum to 1. So could this be so the way to get to 1 is either 2 from the 2 group, but 8's already taken. I could still do 2, 5 with 2, 5. Or I could do a 0 group and a 1 group. That seems a lot easier. How about here? I can do the same thing. So either 1, there's no 4 in either of these. So this is not, to get 2, there are 2 ways to do it again. Either 2 from the 1 group. So since 7 is taken, it'd be 1, 4, but 4 is taken here. So there's no 1, 4. So this is something from 3 or 6 and something, I guess, yeah, 9's taken both places. So something from 3 or 6. This can't be 6, but this could be. So this is either 3 here, 3, 6 here. This could be 2. It's either 2, 3, which is very limited, or 3, 6 with 2, 5, 8, which is much more open. if this is 2, this becomes 3, 4. That seems pretty likely, actually. Okay. Okay, how am I going to make more progress? 9 is here. 8 is here. Doing Sudoku now. 5 is up here. 7 is in here with 9. 2, 6. Okay. Nine would make this 1 for the zipper. Because 4 and 7 are taken. Is there anything wrong with that being a 1? I don't think so. Where does 6 go? Anywhere. Okay. 6 also makes us a 1. Okay, how about these? One of these is a 4, 7. So these now can't have, these can't be a 1, 4 pair anymore. So one of them is a 2. And the other one is a 3, actually. Wait, hold on. Is that right? No, we're going to 7. So we're going to 1. So it can't be 2, 5 because 5 is taken. So one of them is a 4. And the other one is a 3. Okay. And so either way, they can't go over because these are 5 apart, I think. They're definitely more than 4. 1, 2, 3, 4. They're 6 apart. So these are 6 apart. They're not this needs if this were a 3, it would need a 4, which would be here, so it can't go over. So if this is a 3 or 4, it goes up or down. So 3 couldn't go up. 3 can't go up. One of these is a 4, which makes this a 1 and this a 4. The 4 has to go up. So one of these is a 3, actually. That is too confusing. One of these is a 3. I don't know how to mark that. 3 with 2, 5, 8 seems pretty likely. 3 with 1, less likely. 3, 4. I don't know. What about these 10 cages? Because 1 and 4 and 7 are all gone. So 8 with 2 seems pretty easy. 7 is gone. 6 with 4 has to go up. This could be 6, but this can't. Oh no, neither of them be 6 because of these 6s in the side boxes. So it's not 6, it's not 7. It could be 8. Or 2, 3, 4. I'll just fill in for now. How could it be 2? I have to put an 8 on the side, which is okay. 3. This one can't be 3 because we would have to put a 7 here, which conflicts with that marking. Well, it conflicts with a 7. Or here, which doesn't work either. So that's not 3. This one could be with a 7 there. In fact, one of these is a 7. And so one of these, one of these, no, it was 7. One of these is 9. Okay. But yeah, 8 could put 2 either place. 4, 1, 2, 3. 4 could put a 6. In fact, it does. So whichever one of these is a 6 gets the 4. This is not 4. So this is not 6 because the 4 needs the 6. Oh, but neither of them have to be 4. Yeah, no, that's right. Neither of them have to be a 4. This could be 2 or 8. 2 will put an 8 here. 8 will put a 2 here. 4 will put a 6 here. 4 gets a 3. It could still be here. 2 puts an 8 here or here. No, sorry, not here. 2 puts an 8 here. 3 puts a 7 here. 8 puts a 2 here. I don't know. I don't know. 9. Yeah, so one of these is a 9, 7 pair to get to 7. And the other one is a 2, 8 pair. This is 2, 8, 9. This is 2, 8, 7. Does 2, 8, 9 help me at all? 2, 3, 4, 5, 8, 9. Not quite. 9 is on here, so that's not 9. That's 5. That does help me. Um, why did I say 9 had to go here? I mean, now I'm wondering if I did that incorrectly by missing this 9 here. I think I just might have meant, hold on, let me go back a little bit and see why I did that. Why did that have to be 7? Oh, because this had to be 7 and 7 had to pair with 9. No, that's correct. Okay. Then what? This 4 still needs a 6. That's one of these. Okay. I'm just not sure what to do. Can I do something here with this? So if this could still be 2, 5. It'd have to be 2, 5. Otherwise, it's a 3 or 6 with a 1, 4, 7. And I don't see. My modular lines are kind of all gone. I don't know what to do now. It's got to be something to do with one of these cages. Oh, the 4, which is one of these 6s gets a 4. This 6 would get a 4 here, but now I know the 4 is here. So that's the 6. That's the 1. That's 6. That's not. This can no longer be 4 because this 6 is where. Oh no, it's this one. This still can be 4. Okay, that's wrong. But the 6 has its 4, and the 1 has its 9. 4 needs a 3, which could be there or there still. I keep going back to that. One of these is a 4 from this 3. The 4 gets a 3 from one of these. So one of these is a 3. If this is the 3, we get a 1 here, which it can't be because of this one. So this can't be 3. This is the 3, which gets its 2 here. This can't be 3, so this can't be 3. This can't be 4 either. We get a 1, 2 pair here. That can't be 2 anymore. 8 still works with 2. And then I get, this is an 8, 9 pair now, which means this is a 2, 7 pair. Therefore, this is 3, 4 with I get a 5 in here. This is not 3. Could it be 6? It could still be 6, 1. Oh, it can't be 6, 1 because 1 is gone. 1, 4, and 7 are gone from here. So this is either in the 2 group or it's a 3. If it's in the 2 group, that's also in the 2 group. So it's a 2. So if this is a 5 or 8, this is a 2. Hold on. I'm missing something up. Yeah. Hold on. Let me go back. Much easier. 4 makes this a 3, which puts the 4 here, which makes this an 8. Oh, this 4 has been sitting at that 4 the whole time. 8 makes this 2. Oh, yeah, because, hold on. 8 could make this 2, but then this 2 would need an 8. It can't go here because of this 8, and it can go here because of this 8. So 8 does make this 2. And 8 here. What's left? 6. 4 is gone. That's a 6. This is a 4, 8 pair. 3 makes this 4, which makes this 8, 4. I get this is a 7, 4 pair now. The 3 gives me this 4, so that one goes away. 8 makes this 9. This digit is a 3. I get a 1 over here. This becomes a 5, 8 pair. You know how that goes. So now this is 2. So this is also from the 2 group. So it's not 7 or 9. This is a 7, 9 pair. This is a 2. I need another digit I know that, which is a 1. Not here. That's not 5. 2 can no longer, it can no longer be 2. It can only be 8. That's a 3. 7 can't be there. So 7 is here. Makes this 9. This is gray. Are they all done? 4. That can't be 3. So now that's 3. And these are done. So they're all done. I'm gonna get rid of the coloring. Still don't know the, no, they're 3, 6, 6, This gets a 3. Not here, so that's a 5. 1, 3. And now I should just be able to finish this off fairly quickly, hopefully. 8, 6, 7, 1, 5, 9. Is that right? I think so. 1, don't know that yet. Okay, these are from 3 and 6. These are from 2 and 6, 3. What's left? 1 and 9. Oh, did I do it? I did. Okay, cool. Yeah, that felt pretty good. I really like this puzzle. So thanks, heliopolix, for sending that in. And yeah, that's it. Thanks for watching. Hope you have a good one. Bye.